So we will start with evolution of advanced research computing, including mainframe, clusters, distributed computing, and then cloud computing, followed by a discussion about the definition of cloud computing and the benefits of using cloud. Then we will talk about two main categories of cloud computing: private cloud and public cloud. So the Alliance Cloud is a large private cloud, and some commercial clouds like GCP, AWS, Azure, they are called public clouds. And then we will talk about cloud storage specifically, because there are at least four types of cloud storage in our Alliance Cloud. And at the end, I will do a quick demo about Abeilus, which is the largest cloud of the Alliance, and then GCP, which is the one we use to support our researchers using the commercial cloud collaborate with Google. Okay, let me move on. First, evolution of advanced research computing. This slide shows that there are at least four stages from the mainframe to PC/clusters to distributed computing/grid to cloud. So as we can see that in the mainframe era, it features high performance, high capability, capacity, and of course expensive because it's centralized everything in the big box. And it's not so flexible because yeah, it's obviously it's hard to add stuff or remove stuff from it, and you cannot bring it to somewhere else. Yeah, so later personal computer was developed. Um, So we researchers found that we can use multiple PCs or personal computers to connect together to form a farm or clusters. Um, so many computers working together to do batch computing jobs. So that means we instead of run one big job, we run many jobs to many computers in parallel. So it features multiple compute nodes, batch submission, job scheduling, because we need to schedule jobs to certain resources. And comparing to the mainframe, it's much cheaper and it's more flexible because we can add more computers or remove some computers. Yeah, it's very easily to do that. So if we can call the mainframe era the centralized era, the PC cluster can be called individualized era. And then later, researchers found that just one or two clusters may not work, may not be sufficient. So then they developed an idea why we don't connect multiple clusters from different places together to do even bigger jobs. So that's called distributed computing. So those computer resources are distributed or scattered in different regions or different countries. Yeah, we connect them together to do one job or one big job or a big project. So that's what the distributed computing and eventually the thing called grid computing was invented. So in this stage, it features multiple distributed clusters, global scheduling, because um, instead of just schedule jobs in one cluster, in this stage, we schedule jobs first to one region or one site, then one site, and then one cluster. So there are 2 to 3 stages of scheduling in grid computing. So, and it also features global data transfer because you need to transfer data from one place to another place to do jobs on different computing resources. And also virtualized organization. What's that? Virtualized organization means that in the grid computing, one person could have different roles um, that can do different work in different projects. Yeah, and why it's visualized? Because it's not like in a real entity you assuming one role. In the grid computing, you can assume different roles. Yeah, and then also features unified security infrastructure. Um, Based on the so-called Grid Security Infrastructure (GSI) and down to PKI, public key infrastructure. Yeah. So all those features compose the so-called grid computing that can support a huge amount of jobs, very large project. Yeah. For example, one of the projects I'm involved is called Atlas. That is from the Large Hadron Collider. Um, the experiment is at CERN, eh, on the border between Switzerland and France. Yeah, and it won the Nobel Prize in 2015 to find the Higgs. Um, why we build this experiment and the grid computing to support this? Because to process the data produced from LHC or Atlas, each year there were more than dozen petabyte storage to process. In 10 years ago, that's huge amount. That's not affordable by one site or one country or even one region like Europe. They still cannot afford it. So the gathered computing resources gathered different countries to join together. So we eventually built up such thing called the worldwide LHC grid computing, WLCG, to support this huge project, and then eventually achieved some goals like find the Higgs boson. Yeah, yeah, it's still in use, but nowadays it has become very rarely used because why? It's too big for just regular projects. We found that it's not so convenient for small scale projects. That's why the cloud computing was invented. One interesting thing is that the goal of grid computing was to give users the convenience of using computing resources as convenient as using utilities. Just like you use the power at home, we want you to just uh, plug your computer into the socket, and then you can get the computing resources as you want. You don't care where it is, where it's from. Yeah, that's the goal of the grid computing. That's why it's called a grid, because it's from the power grid or electric power grid. Yeah, we don't want users to care about what's the details at the back end. You just plug your appliance to the socket, and then you get the power. The same thing. You connect to the grid, you get whatever you want. Yeah, but that's a ideal. Um, it's still there's still a distance to achieve that beautiful ideal. And later we found the grid is a little bit too heavy for regular users. So then we developed the cloud computing, which is way more flexible and more suitable for regular projects instead of those very large high energy physics projects. And the cloud basically have implemented the goal or ideal of grid. So nowadays, um, you can just open your browser and then you can use all kinds of services from the browser. You don't know where the computing systems are really located, right? It could be in Asia, could be in South Africa, could be in North America. Yeah, could be everywhere. Could be in the ocean. Could be in the like Microsoft. They put their machines even really under the ocean. Yeah, to cool down stuff. Yeah. So as users, we don't care. Yeah. So that's the dream or the goal of grid computing. So it's largely implemented by cloud computing. Sounds very interesting, right? So in the cloud computing, it features mainly virtualization. Everything can be virtualized in cloud computing. And containerization, we can make most of the stuff wrapped as a containers, yeah, to run on cloud. Also, such thing called software defined services. We can use software to define a different kind of services. That's basically the exchangeable with virtualization. Yeah. And eventually the goal was to turn everything into a service. By service, it means that everything can be accessible without knowing the backend details, and you can customize it as you want. Yeah. So it's more convenient than the on-premise stuff. You have to do everything by yourself. Yeah. So um, so we can see that in the grid computing era, it's distributed, um, and but in the cloud computing era, it's re-centralized. Yeah, just like um, it goes back to the centralized, like the mainframe time, but it's already upgraded. Yeah. So everything looks um, put in together in one places, in one place that is accessible for different users. But indeed, at the back end, it could be everywhere. But for users' perspective, oh, this thing is there. I can just only use one portal to access nearly everything. Yeah. So, okay. Any questions for this? Let me try to open what's at the chat. By the way, I forgot to introduce about the how to use Zoom to do feedbacks. If you can just click on the what's that the where is it? Yeah, whatever. You can signal me if you feel it's too fast or too slow, or you can just give me a thumb up or thumb down if you like or dislike what I'm giving, and then yeah, for sure you could type some text into the chat to let me know if you have any questions. So let me see. This secret is what the Alliance is providing to Canadian researchers. Oh, good question. Thanks, Caroline. The grid computing, yeah, we have a big amount of resources that are supporting this part in each site. I will be introducing it soon. Um, so yes, at Alliance, we have a big portion of computing resources there to compose the so-called WLCG, which is part of WLCG, to support mainly high energy physics. We have a specific team called Subatomic Physics National Team that supports our researchers on top of those systems. Yeah. So, but it's not just for high energy physics. It's later we developed to support more other disciplines like astronomy, like bio informatics. Yeah. So as long as the project is big enough and it's distributed, that means many different researchers from different regions, different countries um, work together on one project, we can support it using the grid. Yeah. Have I answered your question?
Yes.
Perfect. Okay. Okay, if any other questions, please feel free to shout out or just type into the chat. I really love questions. Yeah, thanks. Next, we'll be talking about what is cloud computing, or what's the definition of a cloud computing? Because I believe that everybody has seen this term everywhere, nearly every day. Yeah. So, but what is cloud computing? I believe everybody can have their own feel or um, definition even about cloud computing. Yeah, because it's like a big elephant. Uh, each person may just touch a part of the elephant, right? I don't mean everybody's a blinder, but yeah. So because it's big enough, everybody has their own use case. So um, that's why you may have a different understanding. That's okay. Yeah. I have I think more than 10-year experience doing cloud computing. Plus, if plus grid computing, that's maybe more than 20 years ago. So I have my understanding. So I give the Ermin's definition of a cloud. Yeah. That is computing resource virtually, collectively provided online as a service or as a services. That's my definition of the cloud. Yeah. You may just disagree. That's okay. Yeah. As I said, everybody can have their own definition. Why I define cloud in this way? Because it features at least virtualization And collective, as I said, it re-entered into the so-called centralized era. And online, compared to the grid computing, as I said, the ideal is to give users the convenience to access the computing resources um, conveniently without knowing where it is, where it is from, where it is located, how it works at the back end. You don't care. So that's why I call it online and as a service. That means not just oh, you get the hardware and you get your you need to deploy them and connect them using network cables, and then you deploy your own operating system and middleware. Yeah, you don't need to do that. So we do that for you, for research, for users. So that's why it's called a service. It's already ready for you to use. That's what as a service mean. And it's customizable. Yeah, you can add things, remove things, and do your own configuration. That's called as a service. So combine this four features: virtualization, collective, online as a service. I define cloud as a this in this sentence. Yeah. So feel free to give your understanding. Just type into the chat. Indeed, I should have done this before I'm showing off my definition. Yeah. So, okay. Let me know you what do you think? Okay. Next, um, virtualization. Um, I just want to talk more about this because the cloud computing is basically established on top of virtualization, um, including hardware virtualization, service or server virtualization, storage virtualization, network virtualization, application virtualization, and even management virtualization. So you can go through it one by one. Hardware virtualization, what does this mean? Basically, as I said, you don't have to purchase your own hardware, or even you purchase your hardware, you don't have to maintain your own computing center. So you just put the hardware, or we purchase hardware for you, and yeah, we get things um, how to call that installed on the ground, and just power it on and let it run. So that's called a hardware virtualization for users. And then server virtualization. So that means you don't have to install your own servers or services. You don't have to install your own operating system kind of things, middleware. And then storage virtualization, same thing. We purchase lots of disks and put them together in one place or different places, and then present to users. Users only see slice of storage space. Yeah, they don't have to touch the disks by hand, right? Network virtualization, which is even more fantastic because we connect all kinds of resources together using cables, whatever it is, and then present to users. Users can not only can access those computing resources, but also they can be can customize their network. They can say, oh, I want to access this part of resources. and I can use this kind of a network, but you don't need to touch the cables. You don't touch the routers. What do you do? Just to customize the service to do whatever you want. Yeah. Um, Application virtualization, um, it's a up-level virtualization, just like all kinds of applications. This thing is a hybrid. Either we can do it for you, or you can join together to do the things. You can deploy your own applications, or we can do it for you, and then you just use it. And the management virtualization just even higher level virtualization. So that means we provide all kinds of service portals for you to do to present the service for users to more efficiently to use the resources. So you don't have to um, deploy your own stuff to do your own um, everything. Just do it in person. Yeah. So that's the benefit. That's the features of virtualization. Any questions? No. Okay. This slide shows the basically the 3 to 4 layers of as a service thing or definition, starting from IaaS, PaaS to SaaS, and eventually the ideal is X as a service or everything as a service. Um, IaaS or infrastructure as a service is the most basic layer, but the most important layer because, as I said, using the virtualization technology, we virtualize the hardware, network, storage, servers into services for our users, so they can access those basically just like those hardware or servers um, online, and it appears to users like a real machine, but indeed it's just a slice of a piece of resource for our users. So we can call it a virtual machine or a container, um, online storage. Um, so in user perspective, they see them as a standalone computers, but indeed it's just a piece of physical hardware. So in the virtual machines, um, the good example is that the Alliance Cloud, we basically provide virtual machines or containers, and also Google Computer Engine, AWS EC2. Yeah, those systems provide virtual machines for our users. And for online storage, very popular one like a Dropbox. And in Alliance, we provide something called Nextcloud. Um, those are online storage. We just conveniently just get a piece of storage space for each user, and they can drop their data there. Yeah. Next stage is called PaaS, Platform as a Service. In this stage, on top of the IaaS, we do more. We deploy such thing called middleware on top of the infrastructure. So users not only just get the physical sorry, they virtualize the physical hardware and then the virtual machines, They also get the middleware deployed, so they can use it just instantly. They don't have to deploy their own middleware, like the database, like some app engines, and then the higher level is so-called SaaS, software as a service. It's the same idea. We just do more for our users. Um, we can deploy all kinds of software applications on top of the PS and IaaS. So for users, basically what they see, just like they don't have to do anything about the computing part. I mean the deployment. For the deployment, they don't have to do anything. They just use it. Um, for example, Google Cloud Platform provides such a thing called Cloud Functions, or Lambda provided by Amazon. They are called serverless service. Yeah, by the name you can see that the serverless for users, you don't have to run your own server. You don't worry about the hardware network. Um, what you want to do is just run your own code on the serverless services. Yeah, and yeah, eventually everything as a service. Um, that's more than just the IaaS, PaaS, SaaS. You can do more like a business development as a service, management as a service. Um, yeah, all kinds of things. Uh, and this slide shows you the benefits of using cloud. Similar to what I said, just use this diagram to show you more straightforwardly. Um, so from the left-hand side, it's the silo is called private or on-premise. Yeah. So users needs to manage or needs to install basically everything. Yeah, from hardware to network to storage, servers, operating system, middleware, data, um, applications. Yeah, and then using cloud, the first stage is IaaS, infrastructure as a service. So we do the hardware installation, networking, storage, server installation, and then virtualize them. So what the users see is, or they need to manage to do is to install their own operating system, middleware, and then transfer the data and then deploy applications. That's what basically I'm going to show you the Alliance Cloud will be doing. So this is called IaaS because we want to give users the freedom to deploy their own stuff. But if you say, "Oh, I don't care about that. I don't want to do that." Oh, yeah, okay, yeah. Um, we can do more for you. Like, um, other than IaaS, we can do more. Like, we can deploy operating system and then some middleware like the um, application developer environment, uh, like different languages and like a Python, like a C, C++, like a Ruby, and some even higher level platforms. So we can just provide all kinds of middleware. So you just choose one to use. You don't have to deploy it by yourself. You don't care about that. And the software as a service stage, basically, we install everything for you. Yeah, just like I said, the serverless stage, you just run your code, upload your code to the something called a Cloud function or Lambda, and then you run it. You don't care where my server is. No, you don't. You don't even need to know. Okay, so this is a cloud. Yeah. Any questions? If not, let's move on to public cloud and private cloud. Yeah. So why we want to introduce these two concepts? Because later we will see that uh, we, as the research computing group, we provide support, cloud support for our researchers, not only through our private cloud, but also through the public cloud. So the main difference between the two categories is that obviously one is public, the other one is private. Private means the service only uh, presented for certain users internally. It's not open to public. Yeah, just like the Alliance Cloud, we only provide to our researchers uh, across the country. Yeah, non-researcher needs or yeah, so we don't open to non-researcher needs. Yeah. Well, public cloud can be accessed by nearly everyone as long as you pay, right? Uh, so it supports all kinds of users, customers, and using internet to connect to it. And uh, so compared to that, private cloud only uses some private network. Yeah. Uh, and public cloud could be less confidential compared to private cloud, but it depends. Yeah, yeah, there could be some protocols signed with the public cloud providers, so then we can still secure your data. Yeah. So anyway, this is just a basic comparison of these two types, and then we can know what we are playing with, like using cloud, public cloud and private cloud. So this slide shows you that a few popular public clouds like GCP or Google Cloud Platform, AWS or Amazon Web Services, Microsoft Azure, and IBM Bluemix. Those are popular public clouds. There are more, but those are very popular in the world. Here's the main use case of the public clouds at UA, like AWS. Uh, the provide these general IT services, like the web service you're using, and some model project, and they're indeed they are doing more. They are going to support even research needs soon. GCP, as we can see that even today we're using the Google presentation to do this talk, and then we also use Google Mail, Google Docs, spreadsheet to do our work every day. So it's also on top of a cloud, but what the users see is just the from the browser, the applications, right? And there's a very specific system called the Gucci, Google Alberta Cloud Incubator. That's a collaboration between UA and Google um, to set up an incubator That means small scale environment to support our researchers to do their research on top of this cloud, on top of GCP, Google Cloud Platform. There are various different features on top of GCP. Uh, for example, the HPC on cloud. That means you can run your own clusters on top of this cloud. Um, and you can do AI, machine learning, um, natural language processing, data analytics, uh, even some generative AI stuff, uh, database. I'll be introducing this soon. Yeah. Azure is also providing some services for users, but individually. We don't have a collaboration yet as a group. Um, but they are also contacting us to try to support our researchers more. So in the future, if we have this kind of resource, we will provide. We will let you know. Um, Here I just typed as individual Windows use cases, but indeed Azure is not just equal to Windows only. Yeah, they also provide us the simulation as a GCP and AWS does. Yeah, uh, whatever. So we just talked about public cloud. Now let's take a look at private cloud. Um, as I said, the Alliance Cloud is a good example of a large private cloud. It's based on OpenStack. Here, I just show you the internal components of OpenStack and how it works. So from the top, we can see there are users. They access the cloud using the dashboard. Internally, we call it Horizon. And then at the backend, there are different components like compute, uh, storage, block storage, networking, image service, object storage, and more. All of these components are connected using the so-called identity service. Internally, we call it a keystone. So it keeps all the what's that credentials. So to do authentication and authorization. And at the back end, it's the so-called Ceph storage management system. Yeah, the the name of the storage management system is called a Ceph. It's a very high performance parallel storage system. So this is an example of a private cloud run on OpenStack. Yeah, that means we deploy everything by ourselves and then provide to our users. Um, from a user's perspective, they just interact with the dashboard. Yeah, they don't have to touch the backend hardware storage. Yeah, so that's so-called cloud, right? Yeah. Okay, before I move on to the details of the Alliance Cloud, any questions? Any feedback for me? Okay, if not, let's move on. This picture shows you the cloud systems distributed in the country that are the so-called hosting sites of the cloud. Oh, sorry. This one is the high level thing. It's the uh, Digital Research Alliance of Canada. How many hosting sites and support sites are supporting researchers? It divides to BCDRI. Uh, DRI stands for Digital Research Infrastructure, and Paris DRI. We are indeed the Paris DRI, um, and the Compute Ontario, Quebec, and ACNet, the five regions. Yeah. In each region, there are either hosting sites or support sites. Hosting sites means they run the hardware, and the support sites means there are personnel to support our researchers. In total, there are about 200-ish people or staff supporting the researchers across the country. And this picture shows that we have basically four cloud systems. The biggest one is called Abutus, that is located at University of Victoria. Um, it's a specific cloud system, not like the other systems. They are running not only cloud but also cluster systems. For example, Cedar Cloud is located at SFU, and the Gram Cloud at University of Waterloo, and the Beluga Cloud in Montreal. It's called ETS. Yeah, I don't know how to pronounce the French what's French name, but yeah, ETS. Yeah, they are all on top of OpenStack for compute and services, plus the Ceph for storage at the back end. Yeah, that's what we do for our cloud. Oh, thank you so much. Yeah. Yeah, this table shows you a summary of the cloud resources on each site. Yeah, I think this will be useful for you to have a big picture of those cloud systems. For example, Abutus. In total, there are, after recent upgrade, there are 83,200-ish virtual CPU cores. But indeed, this number is basically after the so-called over subscription or over commission. Yeah, that means we virtualized the physical CPU cores and then present to our users. From user perspective, or they still see something like a standalone kind of a server or virtual machine, whatever it is. Yeah, but indeed, it's just like one piece of hardware. We just chop it in multiple pieces and then present to our users. Yeah, that's the beauty of the so-called virtualization. Yeah. So comparing to Abutus, the rest three clouds are relatively smaller, much smaller. Like, but yeah, they after the upgrade, they're still bigger than before, much bigger. Like Gram Cloud, they have 25,920-ish virtual cores, and Beluga 16,384. Cedar is the smallest one, only has 10920. Yeah. Storage part, in total, we provide 7 petabytes of the so-called volume, or you can just think of it as a regular disk space on Abutus. But more than that, we also provide 26 petabyte of object storage and shared storage. It's called CephFS. It's a technical name. It's a shared file system. That means the storage can be shared between VMs or between projects. Yeah, and also NVMe. That's even higher performance disk system. So in total, there are 3 petabyte. That's based on solid state disks, I believe. Yeah. Gram has 4.5 petabyte regular storage, and for object storage, they have 1.3 petabyte. That's a newly added. Um, yeah. For RAM, we have 300 terabyte in total for on Abidos. Yeah, and 27, 36, 15 each on respectively for on the rest clouds. GPU is a very nice feature provided on Abidos. Currently, we have 448 virtualized GPUs. Simulson as the vCPU is also virtualized. Yeah. So that means uh, we make the GPU sliced for our users. So each user can get a smaller piece of GPU because not everybody need so big GPU resource. But if you want more, you can let us know. We can provide bigger GPU stuff for you. Yeah. Later, I will show you how to apply for the GPU resource specifically. Yeah. Currently, only Abidos Cloud provides the GPU resource using the hardware called the Tesla, NVIDIA Tesla V100, H100, and L40s. Yeah. H100 is the highest configuration in Abidos, which is very powerful, right? Yeah, and the L40s specifically for visualization. Yeah, and we have V100. That's the lower performance older hardware. We grant users the rapid access service. That means you can apply for them just anytime in the year. You don't have to go through the competition through the so-called rack. Yeah. So yeah, I will show you later how to access to them. Last item is the database. Abidos provides a database as a service, including MySQL and PostgreSQL. Gram and Cedar also provide the two. Yeah. So that means you don't have to run your own database. You can just apply for this. It's already ready for you. Yeah. That's a comment or question from Caroline. I'm looking at the versions of the slides on GitHub, and the numbers are different compared to your presentation. Can we eventually have access to the update class? For sure, yeah, yeah. Because we recently just upgraded the system, so today I show you the new numbers. Yeah, for sure. I will share with you. Yeah. By the way, the whole talk will be it is already recorded, so I will be sharing the recordings after the whole session, cloud session is done. That's maybe the week after or in 1 week. Yeah, as well as those slides for sure. Yeah. Okay. Um, this slide shows the cloud images supported in our national cloud. Um, What is the image in the cloud or our OpenStack based cloud? Yeah, because different clouds may have different meanings of the image, you know. Yeah, in the OpenStack cloud, the image means basically what we support, what kind of operating systems are supported for our users. So from the list, we can see that nowadays we support Arma Linux, um, Debian, Fedora, Rocky Linux, Ubuntu. Those are the main official operating systems supported. There are indeed more, like Windows, like some user customized operating systems. Yeah, but for the official ones or the standard ones, this is they are in this list. Yeah. Personally, we also support CentOS, but since it's end of support by the company, so we just get rid of them. Yeah, yeah. And the next slide about the cloud flavors. What is a flavor? Again, this is the just the OpenStack specific terminology. May be different from the flavor that is talked in different other areas. Here we call it flavor. Basically means a combo of those hardware like CPU, GPU, memory, disk. Yeah. So we make like a how to call that, a recipe. If you go to McDonald's, say, "Oh, I want this burger with this kind of meat, and add some veggies and cheese." So yeah, and some drinkings. Yeah. So here, a flavor basically means a CPU, certain amount of a CPU or GPU plus memory and disk space. They are divided into at least two to three different types of flavors. For example, P flavors, C flavors, or even G flavors. Yeah. Why? Because they are based on different resources. Later, I will show you why we do this. Yeah. For now, you just want to give you an idea that there are different kind of flavors. Like the P flavors, um, we have this in the list uh, from P1, P2, P4. The first number means the number of the CPUs or virtualized CPUs. P1 stands for um, persistent resource with one vCPU, and the second number means the amount of RAM you will get. 1.5 means you will get a 1.5 gigabyte RAM. And in default, uh, for the P flavors, everyone gets 20 gigabyte root disk. Yeah. While on the other side, for the C flavor, that stands for compute flavor, you get more than just the vCPU and the memory. You also get the so-called local disk space. Why? Because this is for computing intensive, computer or CPU intensive um, jobs. So you want store your data temporarily on the local disk to gain the high performance. Yeah, so that's why we give you not only the CPU and memory, but also the local disk space. So C stands for compute, C1 One is the one virtualized CPU core, and something like a 7.5 or 120, that's a memory, and uh, then 36 or 384, that's the size of a local disk. Yeah, or we call it ephemeral disk. Yeah, later in the storage part, I'll let you know why we call it ephemeral disk. Um, there are there is the third flavor called the G flavor. That's specifically for GPUs. Um, so you can see that more than just a CPU memory and disk, we also have one more thing called a GPU memory. Because each GPU you need a kind of memory to run your to transfer data to it and then to do the data processing. So in the flavor, we can see that G1 stands for one virtual GPU, and then 16 gigabyte virtual, sorry, 16 gigabyte GPU memory, and then C8 means compute um, flavor, um, eight 8 vCPUs, and then 40 gigabyte regular memory for the CPU. Yeah. So that means you use this flavor to gather um, both GPU and the GPU memory and the CPU and the CPU memory. Yeah, to do your work. Yeah. You also get the uh, some local disk space. Yeah. Okay. Next, cloud storage. So we can see that there are four types of cloud storage on top of our OpenStack based Alliance Cloud. The first layer is called ephemeral, um, and then volume, and then shared file system, and then object storage. Um, as I said, if you need some local space for your um, computer intensive jobs, you need the so-called temporary local disk space. We call it ephemeral because it's just temporarily allocated into one VM. It's also virtualized from the hardware on the host, on the physical host. Then we chop them into smaller pieces to allocate for each VM for our users. So from the user's perspective, they see something like a really like a standalone disk, but indeed it's just a slice of the storage from the host. Yeah. When a VM is shut down and then deleted, then those ephemeral disk will also be gone. So this is very important. If you have some important data, we don't recommend you store it on the local disk or ephemeral disk. That's why it's called ephemeral. Yeah, only temporary. Yeah. So if you have some important data, please move to some other disk or storage types. Yeah. Sorry. Um, but the purpose of using this ephemeral disk is to gain the best performance for your jobs. Yeah. The scale of ephemeral disks could be dozens of gigabytes or hundreds of gigabytes per VM, as you can see from the flavors, right? Yeah. Other than ephemeral disks, the rest of three storage types are more persistent. That means even your machine is gone or terminated or deleted, those data are still there. So we strongly recommend you move your data or backup your data in either uh, volume or shared file system or object storage. Why you have different storage types like this? Because for different purpose of use cases. Volume, um, basically you can think as a attached USB hard drive, yeah, to your VM, yeah. But indeed, it's also from the backend big storage. We cut them into smaller pieces to give to our users. They get the slice of storage and then attach to the VM, and those data are persistent. Sorry, and if the VM is deleted, the data is still there. And moreover, for each piece of data, there are replicas for them, um, meaning that if one piece is gone, is destroyed, and we still have other replicas to recover your data. Uh, um, Previously, before we do the so-called erasure coding technology, each piece of data has three replicas. But later we found that this is expensive. So only for some important data, we do the three replica mechanism. For the rest, we use such thing called erasure coding. Yeah. Um, so just use some parity, what's that, disks to just um, for just in case if one piece of data is damaged, we can still recover it. But it's not a three-piece replica anymore. Yeah. Anyway, this is a technical detail. Um, this volume thing, we can think it as a regular external disk for our researchers. Yeah, just attached to your VM. Shared file system, internally we call it CFFS. Um, it's set up for users to share their data between their VMs because sometimes you may have multiple VMs. You want to use the same data. You don't want to replicate them one by one to all the VMs, right? Then we can just give you this space. All your VMs can access the same data in the same location, or even multiple VMs from different projects. For example, you have one project, your colleague also has one project. You want to share data with them. Yeah, you can put your data in the shared file system. It's very convenient, right? You don't have to just set up something like a FTP service or you replicate transfer it manually. That's yeah, really troublesome. Yeah, with a shared file system, it's very convenient. Yeah, and object storage. Why we use object storage? Because we found that the regular data storage sometimes is inconvenient to store something like video, audio, photos, web pages, all kinds of formats of data. They are unstructured, not like for example, the database, relational database. Yeah, it's all structured, all same format. So we use the object storage to store them. It's very convenient. You don't worry about the formats. Yeah, you don't have to format them. Yeah. So and also it features the scalability and availability because we can add as many as possible object storage server in different locations uh, to ensure the availability. Uh, So that's very convenient for system system administration and also benefit users for the performance. Yeah. So other than ephemeral disks, the volume file, shared file system, and object storage, those are three types of external storage. For each project, in default, we can give them 10 terabyte each. Yeah, which should be very decent for you to start your work, right? Yeah. But if you need more, for sure you can we can grant more just through the so-called rack competition. Yeah, researcher what's that? Rack allocation, research allocation competition each year. Yeah, I'll show you later. Yeah. Okay, this is about the storage. Let me see. Um, we got 10 more minutes to 10:30, so then we can have a rest. Okay? After we finish this slide. Okay. This slide shows you such thing called Researcher Software as a Service, which is based on such thing called a CVMFS. It's a very odd name, but don't be scared. Yeah. It's just a system to support the researcher software service and to conveniently present to our users. So it features globally shared software repository. That means tons of researcher-oriented software deployed and ready-made for our users, and including some project-specific repositories like Atlas, Snowplow, GenApp. Yeah, it's centrally maintained for different projects and automatically distributed to users in different places, even different regions, different countries. Yeah, that means you don't have to copy it from somewhere to download it. No, you don't need to do. All you need to just um, mount to your machine. Even on our HPC cluster, it's already mounted for you. What do you need to do? Just run it. Yeah. And but you may want to choose which one you use. Like you may have your own operating system on cloud. You have to choose the one that is that fits your needs, right? The More than that, the benefit of using the CVMS based service is that you don't have to compile, you don't have to update, patch your software, and you don't have to search all kinds of dependencies, which is a very huge convenience for our researchers, right? Sometimes it's very a headache to find the compatible software to your operating system and find all kinds of dependencies, and you need to patch them from time to time to avoid the security vulnerabilities. Oh my goodness, very big headache. Yeah. So yeah, we built up this thing called uh, CVMS or Research Software as a Service. Yeah, for you. This slide shows you the basically what you can see the um, software modules on top of our machines. Yeah, all kinds of software. Indeed, more than that, this is just provided by Alliance or the Canadian national what's that the providers, resource providers. Indeed, using CVMS, we can use the software reporters from all over the world. Yeah. As long as you have the privilege, you can just monitor the CVMS. From the left-hand side, you can see that there are different reporters from like CERN, from US, and from Europe, from Switzerland. Yeah. So if you are in one project, like I said, the virtual you have a VO role, the virtualized organization role. Like you are physically located at what's in Canada, but you have a role in US or in Europe. You can grab the resources from there. You can just use a CMFS and to mount the repositories there, and then you can use the software just like locally. Yeah, very convenient, right? Okay, this slide shows you basically how it works or the architecture of a CMFS. Yeah, from the center you can see there's such thing called a stratum zero. That is the software repository of one project maintained centrally somewhere. And then in the second level, there are many um, Stratum 1 servers. That means they replicate the software that they already made to different regions, like in East Canada, West Canada, or US or Europe. Yeah. And then at the user end, they don't directly access to the Stratum servers to get the software or to download. No, we use such thing called the Squid servers to cache those uh, mostly used software to the Squid servers. So for users that have the common needs, they just access the software from the Squid servers. Unless, oh, they found something new they need to use, they download it from the Stratum 1. Otherwise, they just access it from the Squid servers. That is called a caching servers. So everything is cached there. It's much more faster uh, than accessed from the central servers, right? That's why we use the Squid caching servers in each site, yeah, for our end users. This is the three-layer 7-fast architecture. Yeah, just give you the idea how it works. Yeah, and it's we use this thing called a push technology. Just push automatically the software to different region and then to different site to their caching servers. So that's why for users, what do you do? Just choose the hardware, well, choose the software and then run it. Yeah, very convenient, right? Okay, I think we have done the first part in the morning. We could have 10 minutes uh, breaking time. You can have some coffee or enjoy yourself some free time. And then we can come back at 10:40. Okay? And if you have any questions or comments, please feel free to let me know. I'll be here. Yeah. Okay. Yeah. Thanks, Yuri. Okay, welcome back. You can still hear me, right?
Yes, we can.
Awesome, thank you. And my slides, the access to Alliance Cloud is properly shared, I
Yes.
guess. Good, perfect. Okay, next we will be taking a look of how to access to the Alliance Cloud, what kind of resource it has. Uh, so let's start with the allocation first. We have different categories of allocations. As I mentioned, there's a entry level called the RAS, Rapid Access Service, and a higher level called the RAC, uh, Resource Allocation Competition. Yeah, RAS means that you can access the resource anytime by a request. You don't have to go through the competition in each year in autumn. So from the RAS, we can see it breaks down to two categories. One is called compute, the other one is called persistent. That's for cloud. Yeah. Um, why we do this? Because as I mentioned, this is for different use cases. Let's jump to the next slide. First, we can see that compute means that um, it's for those use cases with high performance processor needs. Um, so basically CPU intensive workloads. For example, you want to do some weather prediction or seismic WhatsApp prediction. So with those resources, you can get the high performance. Those resources basically not virtualized. Yeah. While compared to compute, the persistent resource, they are mostly virtualized. Why? Because each user or each project doesn't need the whole piece of the hardware to run their service, like web servers or database. Yeah. So we just cut them into smaller pieces to present to multiple users to more efficiently to use the hardware. That's why we divide them into compute and persistent, just a way to more efficiently to utilize the hardware on different use cases. Okay, yeah, before I move back, yes, there's a terminology called over subscription. If you see it somewhere, that means we virtualized those resources. Yeah. For example, for persistent part, we can make it up to 10 to 1 uh, versus compute just a 1 to 1 ratio. What's that? 10 to 1 means for one physical CPU core, we can cut them into up to 10 pieces and then present them individually for our users. While the computer part, we don't cut them into smaller pieces to ensure the performance. Yeah. Okay, come back. For the compute part, you can see from the second column, uh, in RAS, we can give our users in default 80 up to 80 virtualized CPU cores, while in the persistent only 25. Yeah. And You don't care about the instance volumes, volume snapshots. That's okay. That's just how do you divide them into how many pieces after you get the results. Um, those are so-called maybe soft limit. That means we can change it for you very freely, you know. But the quota of the vCPU and the memory and floating IP and the storage, they are maybe called a hard limit. Yeah. So for RAM, for each project, you can get 300 in total gigabytes for the computer part. And the persistent part, you can get up to 50 gigabyte. And each one can get two floating IPs. That means public IPs. Yeah. That means your VM can be accessed from outside the world. And in default, each project can get 10 terabyte persistent storage, the regular storage, plus 10 terabyte object storage and 10 terabyte shared storage. So in total, you get 30 terabyte of storage space. Um, that doesn't include the local storage, the ephemeral disks. Yeah, you can still get a few hundred gigabyte ephemeral disks. Yeah, if you are using the compute cloud. Yeah, each category has a 1 year what do you call that lifetime, but for the computer part, there's a wartime 1 month. That means your jobs can run maximally 1 month. After that, you'll be terminated, and you can run some new jobs. But indeed, I thought this feature is implement yet. Yeah. So basically, if you get a RAS project, you get 1 year, 1 year lifetime. Yeah. Uh, so as a summary, for compute needs less than 80 vCPU for compute part or 25 for persistent service and less than 10 terabyte regular storage, you can just request at any time to us, and then you can get it basically immediately in a few hours or less than 24 hours. Yeah, we have already gone through this. But if you need more than RAS, so you need to go through this thing called the RAC, Resource Allocation Competition, which happens in each year at the end of September to the beginning of October. So you need to write a proposal and with the justifications um, to let us know why you need more resources and what's the purpose, how will you efficiently use them. Yeah. So as we know that there are two categories of RAC, RPP and RRG. RRG stands for Resource for Research Groups. RPP stands for Researcher Platforms and Portals. So basically, cloud computing needs you only go through RPP, yeah, because you use a cloud to run platforms and portals. That's what we design in Alliance. Indeed, in some other clouds, there's no such you know, um, how to call that, categorization. Yeah, because cloud we can also run some other HPC clusters inside the cloud. Yeah. But in the Alliance, basically for now, we uh, give users the cloud to run platforms and portals. Some users still also can run some individual CPU intensive jobs, just like the computer part. Yeah, but for clusters, it's just for some small scale use case. However, as I discussed with some of the national team leads, maybe in the future we can also move some cluster needs into our cloud. Yeah. Okay. Uh, as I said, if you need the more resources, you need to compete in EG4. Uh, so just pay attention to it. We will send emails to each user just for each year. Yeah, for this. So after you get your resources, you need to know how to access to them, right? First, if you don't have a Alliance account, you need to get one by clicking this URL. Yeah, you or your PI. If you are a student, you ask your PI to get one, right? After that, you have to request RAS uh, separately. Um, sorry. If you need just RAS, you don't need so much resources. RAS you think is enough for you. You just apply for RAS anytime in the year. There's a link. There are some details. But I already shown the what's that the table of the RAS. Um, Under the table, you can see there's a the request form. By filling out the form, then there will be a request sent to us. Then we will review it and then to see if it's okay to grant you the resources. And eventually, a cloud project will be set up for you with certain quotas, like how much vCPUs, RAM, storage space, volumes, snapshots, IPs you can get maximally. Yeah. But for some specific cases, you can ask for increasing the quota. Yeah, yeah. Just let us know. We can see your justification. Yeah, to see if we can give you some exceptions. Yeah. Okay. This slide shows you the portal of the accessing the cloud. Unfortunately, we haven't integrated the clouds into one portal. So for each cloud, you have to access them individually. Like the Abutus has its own portal, and the Cedar Cloud, the Gram Cloud, each one has their own. But you will use your own credentials, Alliance credentials, the same credential for every cloud. Yeah. So um, so the dashboard, uh, that means the web UI, you'll be accessed to is HTTPS, the cloud name, and then cloud.computecanada.ca. It's still the, I'm not so sure if it's changed now, because personally we were called the Compute Canada instead of the Alliance. Now maybe alliancecan.ca. Anyway, I'll just show you later in the hands-on session, maybe, yeah, or in the demo. Yeah. Other than using the dashboard that is from the so-called web browser, we can also access the cloud using the CLI, that stands for command line interface. That means you open a terminal, then you set up the environment, then you can operate the cloud using command lines, which is more convenient for some developers. Yeah, yeah. In the hands-on sessions, I will show you how to install the environment and then the software necessary to operate the cloud. Okay. After getting your resources and you know how to get access to your cloud, and from time to time you need to know, you may have some questions, issues. You can send email to us. Uh, for the national cloud, you send to cloud at tech.alliancecan.ca. Then a ticket will be generated, and then from a charge system, then distributed to different cloud sites, and then the administrators will receive it and then review it, and eventually solve the ticket for you. Yeah, yeah, you will get an email, yeah, to see the result. Locally, we have 10-ish coworkers to support our local researchers. So you can also submit, sorry, you can also send email to us internally if you want something more handy. But you are encouraged to send to the National Cloud email or ticketing system at first. Yeah. Okay. This slide shows you the status of clouds, where you can see the status. Yeah, there's a specific web page. Yeah, you can see different systems, including the HPC clusters. Yeah. Okay, we just talked about large private cloud. So that's one of the resources we use to support our researchers. As I said, other than the private cloud, we also support our researchers using public clouds. Yeah, let's take a look. Um, Basically, for now, for researcher needs, what we use is called Gucci, the Google Yorberta Cloud Incubator. Um, this is a collaborative with Google to support our local researchers only, and it's a complementary system to Alliance. That means we always encourage you to use the Alliance system first. That's a free for you, right? If you find that it's not sufficient for you, or sometimes you get urgent needs, you want to issue some paper, you want to get some data immediately, or you have some experimental needs, you want to test something, or you find something, some resources not available on Alliance, like some very fancy GPUs or some services, some software, uh, then you can come to us, say, oh, can you help us for this kind of needs? Do you have some good resources for this? Yeah, we can find some good resources for you on top of the public cloud. Why it's called a incubator? Because this is for short-term needs. We don't want you to use it forever for free because this is very costly. Yeah. Basically, it's 3 months to 6 months. Depends on different use cases. We will review your request. Yeah. We can give you at least 3 months to use. Yeah. Um, Later, I will show you that there are different stages of using this resource. Yeah. And this funding is renewed yearly. That means we reviewed year by year if we can continually to support this project or system. Yeah. Um, for the Google Cloud or Gucci, there are different features. You can see there's a long list. From IaaS, that's similar to the Alliance Cloud. You can get virtual machines or containers or even serverless. Yeah, we don't have a serverless provided in Alliance Cloud yet, and some cloud storage. You can also run HPC clusters on cloud for yourself, for your own project. Because in Alliance, it's shared for all the researchers. Sometimes you may want to just have your own cluster to just do something just separately. Yeah, you could run a HPC cluster on the cloud. They also use a Slurm as the backend or a Torque. Yeah, we use a Slurm, yeah, the Alliance HPC clusters at the backend. And the front end, they have something called Open On Demand, which is very straightforward to operate using web browser instead of using command line. But you can also use a command line to submit jobs, to manage your jobs. Yeah, you can also use the web UI, Open On Demand. They also provide a database, online query based on something called Firebase or Firestore, Cloud SQL, including MySQL, PostgreSQL, and BigQuery, Bigtable for the what's that? The online query. And they have a specific data processing toolchain to do this called data analytics. Yeah, it's very convenient because they are for different stage of data processing. They have a specific tool, and then you can chain them together to make the pipeline to process the data. They also provide the specific AI machine learning interface. It's a so-called Vertex AI. Yeah. And on top of that, you can run Jupyter Notebook or NodeLab, uh, and conveniently use results at the back end, like a GPUs, like some software like TensorFlow, PyTorch, or those kind of machine learning software. Uh, You can also use some generative AI tools like Gemini and Cloud large language models to train your own models or fine tuning. Yeah, for different use cases like chatbot or video or image processing, image generation. Yeah, I will show you in a quick demo later. Yeah. And for some specific fields like NLP, finance, life science, biomed, Google developed some specific pipelines. Yeah, which is very convenient for our researchers. You don't have to deploy those stuff from scratch one by one. It's already pipelined for you. Yeah, just like maybe AlphaFold is also included. Yeah. They also provide TPUs and GPUs. TPU is a Google developed that is specific for uh, TensorFlow. Oh no, sorry, Tensor processing. Yeah. Um, so it's similar to GPU, but for different purpose. It's a TensorFlow oriented. So especially provided by Google. Well, GPUs is very generic for all kinds of purposes. Yeah. It includes H100, A100, P100, V100, L4, T4, all kinds of GPUs. Yeah. Yeah, of course, Google also provide some other products that is Google featured, like Google Maps Workspace. this may not be for research needs. Oh, yeah, maybe not. I don't know. Yeah. So yeah, if you want to see some details, you can visit this webpage by clicking the link. Let me see if there's any questions. Can Gucci host highly sensitive data? Very good question. Yeah. Um, how to say? We have a protocol with Google, but that depends on your use case. If your data is not allowed to be hosted in different in like places outside Alberta, that answer would be no, because Google doesn't have any machines located at Alberta yet. There could be some servers deployed in Edmonton or Calgary in the future, but not now. So for those kind of projects, sorry, we cannot. If your data is not so sensitive, that means you can how to call that?
Anonymize them? No.
Yes, thank you. Yeah, then you can move on to the Google and yeah, process it. We have a whole we have a service located in Montreal, in Ontario, yeah, in Canada.
Yeah. Okay.
Okay,
Thanks.
yeah, no problem. Uh, so for users that if you don't have if you haven't been set up for the incubator, you can still access the Google resources like using the so-called free tier. Uh, Indeed, each public cloud has their own free tier. Like Google, they provide a 300 free credit for new customers. And since UA already collaborate with Google, so you can access it for, by using your UA CCID. Yeah. Um, so after the free tier stage, if you feel, oh, I want to really try the what's that, the incubator, yeah, we can we will be happy to join you in and give you 3 to 6 months free trial time. Yeah, depends on your computer needs. Yeah. So after that, if you still want to use the GCP resource, you can apply for the research credit. I can assist you because we work closely with the Google account manager. So for each research needs, we can apply for the up to 5,000 credit. After that, if you still want to use the GCP resource, we can set it up to just bill into your own account, your own speed code. Yeah. So you just go into the pay as you go mode. Yeah. These are the three-stage process of using the GCP. Yeah. Okay. Okay. Before I jump to the cloud storage, uh, any questions, comments? No? Okay. Let's move on. The next few slides, 10-ish slides, I believe, is basically about cloud storage more in detail. Yeah, because pretty a few users sometimes got confused uh, for those different types. Yeah. First, as I already showed you, that is the ephemeral disk. Yeah. So basically, ephemeral means temporary. So if a VM is destroyed, then the disk attached to it is also destroyed. Yeah. So your data will be gone. So very important. Don't put useful data in the ephemeral disk for a long time. Yeah, for the data processing during the computation, for sure, you want to move data there to process it. But you recommend to output your important data to the backend storage. That's a volume, yeah, basically volume does. Yeah. Um, this diagram shows you that even though the ephemeral disk, they are not in the VM, they indeed are also virtualized from the physical hard drive in the host or hypervisor. Hypervisor basically it means the software. The host means the physical hardware. Yeah. So we can see that in each host, we virtualized multiple VMs, including the storage pieces for our users. Each user gets their own VM. Yeah, from their perspective, they feel that, oh, I get a standalone machine, but indeed it's just a um, slice of the hardware. Yeah. Okay. Next, volumes. As I said, volumes can be thought of as a USB hard drive connected to your computer, your laptop or desktop. Yeah, you can detach it anytime. Um, but the data will still be there. Yeah, it won't be wiped. Yeah, that's the benefit of using the volumes. Yeah, it's unlike the ephemeral disk. So this diagram shows you that where the volume located. Instead of running on the physical host, there is a specific storage system at the back end. Your volumes will be from there. And each VM gets their own volumes. Yeah. The next, oh, sorry. One more slide about volume. Yeah. Basically, you can manage your volumes from the dashboard. For example, you can create your own volume. You can extend the size. You can uh, attach to a specific VM or change it to another VM. You can create a snapshot of your volume to make a kind of replica of your data. And you can also change the type. Sometimes you feel, like I said, some data we have three replicas. That's for basically um, OS database like data. Uh, then we give them the so-called three replicas. Or you can just use a regular, not so important type. That's called erasure coding. Yeah. And then you can transfer volume to another project. Yeah. This is also convenient if you have another project and you don't want to rebuild everything, regenerate the data, then you can just move to another project. And you can also make it an image. Yeah. For some volumes, yeah, if it's bootable, you can just make it an image and then make it another virtual machine. Yeah. The next storage type is called a shared file system. Uh, Internally, we call it CFS. Why we use it? Because as I said, sometimes you want to share your data across VMs or across different projects. Before we implement this, every time I have to uh, transfer data from one VM to another VM using something like a NFS or even using FTP or SCP to transfer data, which is not so efficient. By using shared file system or CFS, you don't have to do that. You can just give the access to another VM or another project. They can just access the same data just the same way as you do. Yeah. Okay. Here, there's a terminology called a POSIX compliant. That means um, because at the back end, it's all the technology is based on object storage. While we virtualized, this is another kind of virtualization again. We virtualize this storage to be a file system, and then users can use it as a just a your file system. You can do open, close, read, write, log, stateful. But indeed, at the backend, it's virtualized from the object storage technology. Yeah. Anyway, for users, you don't have to pay so much attention, get too so deep, but just for information. Yeah. So this diagram shows you that similarly from the backend storage system, there are different shares of the what's that the storage, and then shared across different VMs. Yeah. So do you see the difference between this diagram and this one? What's the difference? Can anybody tell me? They look very similar, but what's the difference? Okay. The key difference is that, as I said, or as shown in the picture, a share, well, S stands for a share of storage, can be shared across multiple VMs, right? While a VM, sorry, a volume, where's it? Sorry, here. One volume can only be used by one VM. That's the key difference, okay? You cannot just share your VM volume to another VM. No, that doesn't work. But for a shared file system, a share can be used by multiple VMs. Okay. Uh, this slide, I want to show you very straightforwardly how it looks like in VMs. About the shares. So like a share here, it's named by like dev ermin test one. That's the share name. Just also a slice of storage space. It's 10 gigabyte, and then you can see the green boxes are two virtual machines. One is called AIML01, the other one is called Kube01. But they can share the same they can share the same share. They can share the same data indeed. You can see the UUID is the same, right? Yeah. Okay. Yeah, there are some technical details like share management. It's called a Manila. Internally, we call it Manila, but you don't care about that. What I want to tell you is that you can use this feature to management to do management between different VMs. You can set up a quota, some sharing rules, and privacy, and do snapshots. Yeah. The last storage type is called object storage. Um, why we want introduce object storage? As I said, nowadays we have much more different format of data to process. It's not just those relational database data anymore. It could be different audios, videos, photos, emails, web pages, sensor data, all different formats. You want to process them. So to store those kind of data in the traditional storage system, it's nearly impossible, or it takes a huge effort to make them uh, formatted in the same way. Yeah. Right now, in using the so-called object storage, it's so convenient. It accepts all kinds of data type or format. Yeah, and it's very convenient to scale up or scale out the service. Yeah, and yeah, as a predict that 80% of data in the world will be unstructured data in the future from 2025. Yeah, so that's why it's so important to introduce the object storage. Yeah. Um, there's a comparison between the three types of mechanism to store data. First is so-called uh, block, and then file, and then object. Block means you store your data just block by block, but it's a very high performance because you access data just block by block, and but the problem is that you cannot scale it up easily. It's basically just in one box, um, one machine. You can do this way. And for some data with different what's that meanings, and you want to organize it in different ways, so we introduced a system called a file system. We can put data into different pieces and different places, and uh, get them together, and use a file. Give you a file name. Yeah. But the problem is that with a file system, for if you have tons of files, especially those small files, um, in different categories, different folders, and subfolders. Sometimes, if you want to retrieve them, that's a really, really tough mission. Yeah, it takes a very long time to retrieve a very big amount of files. Yeah, that's the problem. That's the bottleneck of a file system. So we introduced the object storage, which is a flat um, architecture instead of the hierarchical architecture of a file system. In operating system, it's flat. Everything is same level. Yeah. But how it works, we just use a section called metadata to chain um, first we chain all the objects together, and each object includes a piece of its own metadata, not like a file. A file has all metadata, while object storage, each object has its own metadata, and then we chain them together. So then we can access it very conveniently using the object storage access way. Yeah, that's the key difference. Yeah, the flat uh, architecture or mechanism. Yeah, to make it very easy to search and to retrieve, and have better performance than file system. Uh, in this way, we can easily scale it out or up and to make sure the availability. Yeah. Yeah. So that's the key difference of object storage and the other storage technology. Yeah. So this diagram shows you that similarly from the backend storage system, why I just show you the one cylinder, because that's the benefit of using the self managers different kinds of storage types. Just using the one storage management system. From this diagram, we can see that I use a different shape to symbolize different objects. Okay, different objects can be shared for different VMs. Yeah. So that's about the storage. Oh, how to access object storage? Currently, there are basically 2 to 3 methods. First is called S3. That's developed by Amazon. It stands for Simple Storage Service. You use this tool or protocol to access the storage. Every object storage system supports S3. Yeah, so you can just use this tool. Or for OpenStack specific, you can use a system called Swift. It supports both command line or web UI to access your data. Using the web UI just like Dropbox. I will show you later. Yeah, you just upload or drag your file or data to the what's that the web UI. Yeah, or download it. Yeah. Of course, if you are a developer, you can use the so-called REST API, basically HTTP get, put, post, delete methods to access the object storage. Yeah. There's a comprehensive user guide of this. If you can click the link to see it. Okay, I think we have done the what's that the talk part. Next, I can do the demo. Before that, if you have any comments, questions, please feel free to let me know. We get 30-ish minutes for the demos. Good. Okay. The first thing I want to demonstrate is the Arbutus cloud, because some people may not have time to join my hands-on sessions. So I just want to make a quick demo about the Power Cloud and the Alliance Cloud, and the what's that, the GCP as a public cloud. So first is the Abidos, which is the largest cloud system in Alliance. So I just simply input this URL. Yeah, it's still Compute Canada. Yeah. Okay. Then use my Alliance account and password and sign in. Yeah. You can see the first page is the overview. That means how much resource you have and how much you used. The red means you already used it up. And yeah. Oh, by the way, this is not my project. Sorry. I should click on this. Indeed, there's some problem with my own account to access the instance. I'll switch to the guest account. It should be better. I don't know what happened to my account that I cannot show the instances. So here we can see this project is specifically for this training purpose. So this is the project name, and this is the username, and this is the overview page. And then if we click on instance, that shows how many VMs are running here. Yeah. By the way, this is the computer part. And then storage part is on the volumes tab, and network part, and orchestration, object storage, and share. I have introduced most of them, I believe. For the compute part, yeah, other than the VMs, we can use this page to launch instance. For example, if I click on the button, you will show me this window, and I'll fill out the what's that necessary information. For example, give it a name and give it a flavor. Means which combo of results you want. This project is persistent uh, resource, so you only see P flavors. If it's on computer, you should see C flavors. Yeah, we just divide them. Yeah. Network, you choose a network, internal network, and then you give a so-called key pair. Yeah. In the hands-on session, I will show you the detail how to set it up. But now I just you can just see how it works, and then we can just launch the distance. Oops, what happened? Oh, I should choose a availability zone. Yeah, this is not so smart. Sorry. It should do it automatically. Because this is a homebrew cloud system, something not so automated yet. What? Something wrong? Oh, I haven't chosen the source. What kind of image I should use? For example, which kind of operating system I want to use. If I want to use, let's say, Alma Linux 9. Sorry about this. I went too fast. And the flavor is ready. And then we should be good to go. Let's see. So then we can see that the new VM is spawning. And it gets a internal IP address already. At the same time, if we want to access to it, we can just associate floating IP to it. Just means you allocate floating IP or public IP and then associate to it. I have already assigned a few, so I can just conveniently just use it. So now you can see that the state is running for this VM and it's active. So it means I can use it because I already got the public IP. So it means I can access to it. Yeah. I don't think today we have to go too deep to access to show you how to access to the VM. Yeah. So if you want to join the hands-on session, I will show you the details. Okay. This just show you basically how it works. And the images, as I showed, yeah. By the way, you guys can see my web browser, right? Not only just the slides, right?
Yeah, we can see you how to set up the virtual
Very
machine.
good, very good. Thank you. Yeah. So you can see the images. It's more than what I showed you. Why? Because other than those official images, there are some private images set up by different users. Yeah. Some users just make it public, so like shared. Yeah, we can just see it. Yeah. Okay. The key pair thing is that the credential for you to access the cloud resource. I will introduce the details in Wednesday talk. Okay. Volumes is basically the storage part. Yeah. From the volume tab, you can create your own volume. That means to grab the piece of storage from the backend system uh, to attach to your VM. Let's say test volume 1 and leave this as is default. Here you can see the different type of volume. As I said, for regular non-critical data, we don't have the 3 replica mechanism. So you can use the default one. That means not so important. If it's for something very important, you want a high performance and 3 replicas, you can choose the OS or database type. Okay, this is more costly than the regular one. Okay, and then you can give it a size like a 10 gigabyte, and forget the rest of things. You don't worry about that. Yeah, they just create it. It's should be done. For volume, you can do some operations like you can manage it. Manage means basically you attach to instance. For example, I can attach to any of them. Yeah, this is the newest VM I just spawned, so we can just attach to this VM. It says attached. Okay, let's go back to the VM or instance. By the way, instance in this OpenStack cloud is exchangeable with VM. Okay, because instance can be containers, can be VMs, can be serverless stuff, but here it's just VMs. Okay. So now let's click on the Tesla 3 VM. Let's see if we get it. Yes, we get this one. Yeah, the volume. That means we get a 10 gigabyte more storage space. Okay. As I said, you can back up your volumes. Uh, Basically here, the backup means you produce a replica of it. Okay. And then you can also create a snapshot for your volume if you think your data is so important. Yeah. Um, Network part, we have already basically set a network for you already, so you don't have to do your networking thing unless you have very specific needs. You can also create your own network. For example, if you have a project with many people, you want to divide them into different small groups, and then each one gets their own sub network. Yeah, you can do the thing. Yeah, but for now, basically users don't worry about the networking part. That's the another beauty of cloud computing or virtualization, right? Here, one important concept is called security groups. Um, there could be many different purposes of your services, and you can manage them to open to different targets. You you by set up different security rules. Basically, a security rule means what kind of port, what kind of service to be opened to what kind of people uh, uh, in which locations. Yeah. So, for example, um, by the way, security group is a group of rules. Yeah. So it's so many layers. Yeah. So you can create a specific security group, or you can use the default one for everything. That up to you. For example, for me, I set up the web one for all kinds of web needs, including port 80, port 44.3, or even 8080, all different kinds of web use cases. And inside, we can have different rules. Yeah. For example, if I want to create a new rule, I can add a rule. I can click on this button. Here you can see so many different protocols. For example, if I want to open the SSH access to uh, somebody from somewhere, I can just choose SSH1 and give the IP address of the user, open it to the user's IP address. Yeah. Or you can just give to everybody. 0.0.0/0 means to all over the world. If you want to be more secured, you should put some specific IP or IP ranges. Okay, this is a important concept of security. Yeah. Floating IP, basically, I said it's a you can think it as a public IP. It's not necessarily public IP, but here we make it a public IP. Floating IP, why we don't call it public IP directly? Because the floating IP can be other kind of IPs as long as it's routable. It means you can be this resource can be accessed from outside the world, not only just not necessarily to the public, right? Yeah, but in Arbutus we just make it public, so you can just think it as a public IP. Once your VM is set up, you can only access to it after you set up a public IP for it. Yeah, okay. And for this is a network part. some other features like object storage. Here we can see in this tab, there's a container tab, subtab. This is very confusing. This is not the container we talk about. We will be talking about on Friday. This is just a subfolder. You can see it's just a folder, and you can create your own container like what I created here, and then in this container you can add a folder. Oh my goodness, I don't know why they made the so complex. And then you can upload your files. You can transfer files here. Choose a file and then upload to it. This is just online storage. Yeah. At the backend, it's based on the object storage. It's maybe very complex, but from the front end, it's very easy for users. You just upload to it, right? And there's a specific web page to tell you how to use the object storage. Sometimes for the developers, they may want to not only just to upload from this web UI one by one. That's a really burdensome, right? You can use a command to do it in a batch way. And in that web page, will show you the exact instruction how to use it more efficiently. Okay. Other than upload, you can also download, right? Yeah. Share, as I just introduced, is the shared file system. Each project can have their own share or shares. You can create your own share, give it a name, and the size. Type is a CFFS. Yeah. Availability. Nova is the internal OpenStack built-in zone. Yeah. Create. Ah, something wrong. Doesn't matter. This is just a demo. After created the share, you can access it from different VMs or different projects. I already showed you, right? Yeah. And you can also do something more. Yeah. Okay. This is basically what it looks like, the OpenStack cloud. Yeah. This is basically just run VMs. Okay. While the next stage, I want to show you about the GCP. Will be way more complex than that, way more features. Okay. Let's see. GCP console. I click on console. And then I have lots of projects. So let me choose that. Yeah, let me choose the internal one. Okay. And this is just the overview page. Yeah, let's go dive inside. From the left-hand side, we can see that it can not only do the VMs, but also can do like containers using Kubernetes. Also can, of course, there are a big amount of storage for users to use, and the database, and some relational database access, and serverless called Cloud Run. Oh, thanks, Caroline. Yeah, I'll be sending the recordings to all the audience soon. Okay. And more than that, if we check the all product, we can see that many other features. other than what I talked about, computer engine for VMs, Kubernetes for containers, and even VMware, it can also do batch jobs, for just like the HPC clusters. And the storage, there are different storage types, and also can do the data analytics. There's so many tools for each stage of a data processing, including data prep and data flow, composer, data fusion, PubSub for the messaging queue, and data looker for the the visualization, and for some specific fields like healthcare, financial, life science, Earth Engine, it has specific pipelines for them. Networking, you don't worry too much about this, unless you are a system administrator. Serverless, as I said, it has a Cloud Run or Cloud Functions. That means you can run stuff. You don't want to see any VMs or containers. You just run such thing called Cloud Functions. Yeah. Database, all kinds of database from small scale to very huge scale. Yeah. All kinds of scale, SQL or no SQL, JSON like data models. Yeah. In-memory database. Yeah. What else? And also some CI/CD tools like Cloud Build or Jenkins, like Jenkins, and some artifact registry, Cloud Deploy. Yeah. One more important part of GCP is that it can support AI machine learning using such thing called Vertex AI. Yeah. You can see so many features, but let's dive into Vertex AI. Yeah. Basically, we can see that other than we do our own stuff, the AI machine learning programs, we can also use their already generated or installed, deployed stuff like to do chat, vision, speech, kind of AI stuff. Or we can also tune our AI on top of the models, uh, or we can drag some open source models from Hugging Face or some other places to do the tuning. Yeah. Oh, so many. I cannot go through one by one, but let's take a look at the workbench. Here we can see that we can create a new instance. Here the instance is not a VM anymore. This is a kind of Jupyter notebook. At the back end is a container. So we can choose what kind of operating system and what kind of software to use for the AI machine learning, like PyTorch or TensorFlow. I just randomly choose one and can attach a GPU. We could have different GPUs, but here in default only this T4 GPU. Yeah, and then create an instance. Yeah, then you can start. You will see a Jupyter notebook. Yeah. Oh, here it's a Jupyter Lab. Yeah, it's yeah, upgraded version of Jupyter notebook. So it can conveniently just do the AI machine learning projects or programming there. Yeah. Okay. Let me see something else. This is a chat. This is a generative AI. For example, we can choose different models of a Gemini from the latest one, the 2.0 Flash. Or we can even use the Cloud 3.5 or Llama. Yeah. It supports 3 kind of models. Yeah. Yeah. And also you can tune it, as I said. Yeah, you can create a tuned model. Yeah. To get your own data set to tune it. Okay. Let me see. Anything else? Yeah, that's about it. Mostly the researcher related stuff I already showed you. Yeah. And the rest could be the very Google specific stuff like Google Maps, Google Workspace. Yeah. So if you are interested and you have a good computing needs, you can request this resource. As I said, after the review, we can give you 3 to 6 months time to try things out. Okay. I think that's it for today. Any questions, comments, feedbacks?